today's video. Today I'm going to talk about binary tree reconstruction from traversals. We will learn how we can rebuild a binary tree just by looking at the order in which its nodes are visited. A binary tree has a hidden structure. Even if we don't see the tree directly, we can unlock its structure using traversal sequences. Traversals tell us how nodes are visited, and with the right combination, we can rebuild the exact tree. A tree traversal is a method of visiting every node in a tree exactly once in a specific order. There are three types of traversals: Preorder, Inorder, and Postorder. Each traversals give us different information about tree. Types of traversals. Let's quickly understand each one. Preorder traversal. Visit the root, then left, then the right. In Inorder traversal, visit left, then root, and last the right side. In Postorder traversal, visit left, then right, then the root. Among these, Inorder traversal is the most for reconstruction. One traversal alone is not enough to rebuild the tree. Different trees can produce the same traversal sequence. The key idea is, Inorder traversal shows a boundary between left and right subtrees. When we combine Inorder with Preorder or Postorder, we get unique tree. Let's see how traversals reveal the tree structure. Here's how reconstruction works. Preorder tells us the root first. Postorder tells us the root last. Inorder tells us what belongs to the left and the right subtrees. Once the root is known, Inorder spills the tree, and the process repeats recursively. Recursive steps for construction. The algorithm follows these steps. Identify the root. Find the root in the Inorder sequence. Build Inorder into left and right subtrees. Match nodes from the other traversals. Repeat the same process recursively. So you understand how Postorder plus Inorder reconstruction works. So let's understand this with an example. First, Postorder. There are 2, 4, 3, 7, 15, 12, 19, 6. As for Inorder, we should write this in ascending order. 2, 3, 4, 6, 7, 19. As for the Inorder, visit left side, then root, and the right side. So let's find the root. From the post order, the last element is always the root, which means 6 is the root. 6 here. In Inorder, let's find the 6 where it's located. And here's the 6. 6 is divided the sequence into left and right. This is the root, and these are the left side values, and here right side value. So which means 2, 3, 4. And for the right side, 7, 12, 15, 19. So let's move to the right subtree. Remaining post order for right subtree are 7, 12, 15, 19. And there is 6 already taken. Now let's move to the 19. So 19 will be the root. So in Inorder, there is the 19. To the left, there is 7, 12, 50. So let's write down 7, 12, 50. As for the right side, it is null. So next, we will find the next root from 7, 12, 50. In post order, 6 already taken, 19 is already taken. Next, move to the 12. So in here, there is the 12 in Inorder. So let's write down. As for the 12, there is the left side 7, and for the right side there is 50. Now root 6 right part is over. Let's move to the left side. In here we should find the root in Postorder. So let's move 6, 19, 12, 15, 7, 3, 4, 2. So 3 is the root in 2, 3, 4. As for the root 3 in order, there is the 2 in left side, there is 4 in right side. So this is the Postorder plus Inorder binary tree reconstruction. Now let's move to the next reconstruction using Preorder plus Inorder. Now let's move to the next example, binary tree reconstruction using Preorder plus Inorder. So in Preorder there are 6, 3, 2, 4, 19, 12, 7, 15. And in order traversals, we should assemble it in ascending order, and we will get 2, 3, 4, 6, 7, 12, 15, 19. Our goal is to reconstruct the binary tree that produces both these sequences. From preorder, the first element is always the root, so 6 is going to be the root. So the root of the tree is 6. Now we find 6 in the in-order sequence. In here, 6 is the root of in-order. So to the left of 6, there are 2, 3, 4. And to the right of 6, 7, 12, 15, 19. This tells us which nodes belong to the left subtree and right subtree. For the left subtree, preorder segment 3, 2, 4. In inorder 2, 3, 4. So let's write down in preorder 3, 2, 4 and inorder 2, 3, 4. In preorder, as I mentioned, first element is the root. So 3 is the root. In inorder, here 3 is the root, and to the left of 3, 2. And for the right of the 3 is 4. 2 becomes the left child, 4 becomes the right child. Now the right subtree. Let's write down preorder. Nineteen, 12, 7, 50. And as for the Inorder, 7, 12, 15, 90. In preorder, 19 is the root. So here 19 is the root. To the left of 19, there are 7, 12, 15. 7, 12, 15. Non-right subtree, so it is gonna be null. And next element in preorder is going to be the 12. So root of the left subtree of 19 is 12. And in order, 7 becomes the left child of 12. 7, and here 15 becomes the right child of 12. After completing all recursive steps, the final tree looks like this. 6 is the root, 3 and 19 are its left and right children. 2, 4, 12. Branch further, and 17, 15 complete the structure. This tree is uniquely reconstructed. So, thank you guys. I hope you get an idea about reconstruction of binary trees. Please like and subscribe my channel. Thank you for listening.